Hi, this is Mrs McTaggart. In this video we're going to be looking at using scale factor, and particularly to find a missing length in another shape. So let's look at this. So in maths, two shapes are said to be mathematically similar if one is an exact enlargement or reduction of the other. So think about if you've ever been creating some kind of file or PowerPoint and you've had an image and you've just stretched it out without altering it at all or without distorting it. That's you made an exact scale enlargement. In maths, what we do is we put a numerical value to this enlargement or reduction, and it's called the scale factor. Now, you'll have done equivalent fractions before in maths, and you'll have used this skill already, but just maybe not in context. So what you have to do to identify your scale factor is sometimes you can see it just by looking. So, example, you can look at this one and think, well, that side's gone from 2 to 8, so I've multiplied by 4. So the scale factor in this case would be 4. This new shape is 4 times bigger. Here is one where it is a reduction this time. So this shape has been reduced, and if you look at these measurements, I've gone from 6 to 2, or I've gone from 3 to 1. So I've reduced it by 3, but we wouldn't say that's a scale factor of 3 in this case, because if your scale factor is 3, that means 3 times bigger. So what can we do to make it look like 3 times smaller? Well, that would be called a third. So dividing by 3 is the same as writing a third. So in general terms, let's put it this way. Your scale factor is what you multiply by to get the length in your new shape. I'm going to use this phrase new over old. Now I've got this same video made where I've used big over small, but I'm going to use new over old. I think it just simplifies it a wee bit sometimes. So you saw that I had two shapes. The new one is always going to be the one to the right, the one that's got the missing side in it I'm trying to find. And we've got two pairs of measurements where we'll put the new measurement over the old measurement. And we'll look at this at a wee second in action. But a good wee gentle reminder is if something's getting bigger, you should have an enlargement scale factor of a number bigger than 1. If something's getting smaller, your reduction scale factor should always be something less than 1, like 1/4, 1/3, 2/3. So I'm going to do 4 examples here. So here is my first one. So these shapes are mathematically similar. We have gone from a measurement of 3 to 8. So these are the ones that we're going to use as our new and old. So this was my old shape. My old measurement was 3. My new shape has a measurement of 8. So when I do my scale factor, I'm going to do new over old. And then I'm going to put the 18 over 3. And then 18 divided by 3 gives me 6. So the scale factor is 6. Now you might have just seen that. You might have gone, oh well, 3 times 6 is 18. So we're times by 6. But there will become cases where this fraction really helps you out. So new over old. And then so if your scale factor is 6, the missing side, which I'm going to keep calling x, will be your scale factor of 6 times what matches up with the x in the previous rectangle. So 6 times 5, which is 30. So my missing length is 30 centimetres. Let's have a look at my second one. So this time my shape has got smaller, so I've got a reduction. So this is my new measurement. This is my old measurement. So my scale factor will be new over old, so 4 over 20. If I simplify that down, 4 times table makes that 1 over 5. So my new shape is a fifth of the original one. So to get the missing side x, I do 1/5 times what marries up with the x in the previous shape, which is the 15. So I do 1/5 of 15, which is essentially 15 divided by 5, which gives us 3 centimetres. So remember, what you cannot do is say your scale factor is 5 and then divide by 5. It doesn't work like that, I'm afraid, if you want full marks for consistent working. New over old. So I notice it became a fraction. Again, you might have just spotted that I'm dividing by 5 to go from 20 to 4, but it's remembering your scale factor is then 1/5. Now, these have been whole numbers, and for a lot of people, this is as far as we would go. So if I was teaching third level with my first or second year, this is probably as far as it go. When I start to push into National 5, a wee bit trickier, we can go into fractions. So this might be a place to stop on this video for you. If you want to challenge yourself, we're going to look at some trickier ones where it is not nice scale factors. So if I have a look at this one, I have a picture frame as an enlargement. So when I do a scale factor, I'm going to do new over old. So here is my new measurement. Here is my old measurement. New over old would give me 25 over 10. 25 over 10 will simplify down using the 5 times table to 5 over 2. So I'm going back and using that simplifying fraction skill from earlier on. and maybe S1 or primary. Now you can leave it as 5 over 2, or you might want to show off and convert that to 2.5. However, I prefer the fraction. So then my missing length x is my scale factor of 5 over 2 times what marries up with the x in the other one, so 8. And 5 over 2 times 8, I'm going to do good old divide by the bottom times by the top. 8 divided by 2 is 4, times by 5 is 20. So the missing side is 20. Again, I did say you could have used the 2.5. 8 times 2.5 would have been your alternative working there. 8 times 2 is 16. Half of 8 is 4. Add them together, you'll still get the answer of 20. Okay, let's look at reduction where it's sneaky numbers. So in this reduction, here is my new measurement. So you're always looking for the pair that are in the matching places. So new over old, scale factor equals new over old, so 8 over 12. 8 over 12, 8 and 12 are both in my 4 times table, so that will give me 2 over 3. So my new shape is 2/3 of the old shape. So the missing side, x equals scale factor times what marries up with the x. So I'm timesing by 15. So 2/3 of 15, this one I can't turn into a decimal because that is not a nice decimal. It's going to be 15 divided by 3 is 5. 5 times 2 is 10, so that missing side is 10 centimetres. I hope this has helped. Thank you so much for watching. Bye bye.